exactly what that project is, but if you connect the dots, you can. I worked with Peacock, a streaming program from NBC Universal, and I was one of their storage experts across the entire launch process. So those are just a couple of the things that I've done in the past, and now I get to take all of that knowledge and teach and advocate for people to become certified. So today we're going to talk about cloud native deployments and apps and so forth, but I don't have a deck. I don't have an outline that I'm going to follow because I'm really going to lean on what you want to know about it and how I can help you.
Okay, so you could do a quick intro on what it is, because some people don't even actually understand. I mean, we hear cloud native app development, but what actually is it? So we want to know before we start asking you plenty questions.
Sure. Yeah. So essentially, what is AWS, and then what is cloud native and what's not cloud native? I'll kind of touch on those three topics real quick. So AWS, most of you may know what it is, but it stands for Amazon Web Services. Started way back in 2003. If you check any wikis, technically AWS didn't start until 2006 when we first launched Simple Storage Service, or Amazon S3. Then we went to Amazon EC2, which our EC2 Classic just got fully deprecated and it's now retired. Okay, so that just happened a couple days ago. So it's been, 16 years? And then we went to Amazon SQS. Now, those are a whole lot of different services, but those are the first three. Now, we have since grown to the point of where we have over 220. And last time I checked, we had 238 on the products page. Someone keep me honest here and let me know if you find the products page and exactly how many, but it was about 238 last time I checked. And that pace of growth is just it's so impressive, and it does so much for our customers. Like I mentioned, I joined the company in 2015. We had 37 services. So we've grown over 200 by then. So that's AWS and some of the services that we have, kind of where we started. And now what I do, or now with the what is cloud native, I'm going to actually address it from what is not cloud native. Not cloud native means you are deploying into a data center. You're only racking and stacking. You have physical hardware that you're putting into a rack and you're deploying that physically. You have all of your systems physically located. All of your laptops and systems and operations are physically located. Now, cloud native is more about deploying cloud native applications that only use cloud services. We'll focus on AWS today. So with the cloud native solutions, you only use cloud storage. So Amazon S3, for example, for your blob storage, for your object storage. You have Amazon EBS. That's still technically cloud. But people also think of cloud native as possibly a mix between non-serverless and serverless. So that's what cloud native means. You're developing an application within the cloud directly, and it exists only in the cloud. It doesn't run anywhere else outside of that.
Okay, so you talked about people having this mindset that it's either serverless or not being serverless. So what do you have to say about that? I mean, most times I have that in mind. What do you just have to say about that concept?
So with serverless, a lot of people think, oh, what's serverless? Does that mean there are no servers? All it means is servers run somewhere, but you do not manage them. You do not configure the servers. So you don't touch them, you don't see them, you don't configure them, you run your code. Lambda is a really good serverless service that they like to use it for running their code in the cloud. Amazon S3 is also a serverless service. It's a serverless storage service. Lambda is a serverless compute service. Non-serverless would be like an Amazon EC2 instance, a virtual machine that you're going to deploy and configure. It also means that you have the overhead. So you need to patch it, you need to manage it, you need to maintain it, and all of that.
Okay, so you've given a quick. Okay, Kingsley. Kingsley, ask your question.
Okay, I'd like to ask a quick question. So, if, for example, a client has his small application running on an EC2 instance, yes, he's not making use of, he also has a database on an EC2 instance, but he does not apply, say, principles of scalability, he's not auto-scaling, he's not using a serverless database. He just has two EC2 instances, his web server on one, and his database on the other. Can we describe this also as cloud native? Because yes, at this point he's actually using a cloud service, but the principles of high availability he's not applying. He does not apply scalability, nothing. Just two EC2 instances, a database, and a web server.
Yeah, it may not be optimal, but let me actually repeat the question and the scenario just to make sure I understand it. So someone is using two EC2 instances in a single availability zone. So it's not highly scalable, it's not highly available, but that's still technically cloud native. Is that the scenario that I'm answering?
Yes, that's it.
Okay. So because they're using an Amazon EC2 instance and the application is deployed in an Amazon EC2 instance, that is cloud native. Now, is it serverless? No. Is it the most optimal? It depends. It's not like saying everything has to be serverless to save money, because you can run a well-functioned EC2 instance and still make it more operational. Would I do it that way? Maybe not. I would probably say, hey, let me go ahead and beta test or see if it's going to run. I'm going to develop on my EC2 instance, and then I'm going to shut it down once I have it optimized. You can also have scheduled actions to start and stop your instance based on certain days and times and patterns for the access. But I prefer to do more event-driven architecture, or EDA. So if you've ever heard of EDA, let me know in the chat. I would love to actually see that. If you haven't heard of EDA, essentially what that means is something causes something else to happen. Some action causes some reaction. So if I were to upload an object into an Amazon S3 bucket, an object being a file, a picture, a video, or something. And I see Ebenezer says, yep, heard of EDA. So for those who haven't heard of it, I just kind of talked about uploading a file or a picture or a video. That object gets uploaded to the Amazon S3 bucket, and that action causes another reaction. It can be kicking off a Lambda function to go retrieve that object metadata and then put it into a DynamoDB database. It can be anything, honestly. So Event Bridge is kind of the middle piece between a lot of this event-driven architecture. So Amazon Event Bridge is a really cool service. Check it out if you haven't. But that's mostly what people think of when they think of cloud native applications. Can you do it with an EC2 instance? Yes. Can you do it with an RDS instance? That's still technically cloud native.
Okay, all right. Thank you very much.
Do we have more questions before I start with mine? I think I've been asking. So if any other person has a question for Aaron, the floor is open. I feel nobody wants to ask. Okay. Let's give it a minute more.
Yeah, if you have any questions, let me know. And then what I'll also do is...
You don't have to be shy. Just ask the question.
Yeah, come off mute, raise your hand, type your question in the chat. It looks like Samson has the video on. Not sure if that's intentional. I think I see... there's Samson. Hey, Samson, how are you? You can turn your video back on.
You got me there.
It's okay. Turn it.
Hello, everyone.
Turn it back on. Everyone can turn your video back on. It's okay. We can have a party.
I just joined, so I don't have any questions yet.
What I'll do is I'll send a link to my LinkedIn. That's in the chat right now. So if anyone wants to connect with me, please feel free to do that. There's a thing though. I do have like creator mode enabled, which means follow is the default. So if you don't see a connect button, click on the 3 dots and then click on connect. And I'd love to connect with you. If you have any questions outside of this session, feel free to send them to me on LinkedIn and I'll do what I can to help answer. But
yeah, I think someone's hand is raised up.
I see that right now. Yep.
Dorian, can I ask your question?
Oh, thank you. Sorry, can I ask my questions without turning on my video? Is that okay?
Absolutely. Yeah.
Okay. All right. Thank you, Aaron, and thank you, guys. I have a question, and my question actually is still something around AWS, right? I think recently I've been playing around the WebSocket, and I was trying to implement a WebSocket application. And I think one of the technologies that I used was SignalR. SignalR is a Microsoft technology that drives real-time application development. So now my question is that what's the best use case, or what service can be best utilized in deploying in a Signal House service on AWS? We all know that Signal House is a Microsoft technology, yeah, but I believe it should be functional on AWS as well. I was going through it and I come across something because, for instance, I use EKS, Elastic Kubernetes Services, and with the way WebSocket works, it can it can have high utilization on network bandwidth, and network resources, because there will be a lot of data exchange, happening almost real time. So which service is best in deploying the Signal service on using AWS? Microsoft, for instance, they have an Azure Signal service, but I think AWS, I think they've started doing something around that as well. Yeah, because I recently came across a post by one of the AWS architects on how to deploy a Signal service. So what will you advise? Is it better to use a Fargate, for instance, or it can still be better put on on an EKS? So I'm just like, what's the recommendation from this on this? Thank you.
Yeah, you're welcome. So essentially, I'm gonna pick that one apart a little bit and tell you that. So if you ever ask someone a question, most times they're going to give you an "it depends" answer, and the reason why is because I don't think we have all the information that we can really consume to be able to give you the best advice. So what I'm hearing is EKS and like a single service and Fargate. And I'm going to unpack that a bit here, because a single service can run on EKS, a single service can run on ECS, a single service can run on EC2, a single service can run on Lambda, a single service can run on API Gateway. I'm saying a lot of stuff. EKS, Kubernetes service, Elastic Kubernetes service, ECS, Elastic Container Service. What else did I say? EC2, Elastic Compute Cloud. You have Lambda, you have API Gateway. So can you use Fargate with EKS? Yeah. Can you use EC2 with EKS? Yes. That's going to be your base layer. That's going to be your compute layer. With EKS, that is your orchestration service. So you have EKS over here and ECS over here. Think about these two things as your orchestration service. You're living in the EKS land because you're in a Kubernetes shop. Fargate is your serverless compute layer. So Fargate with EKS. So think about it that way. Can you run a single service on it? Yes. Can you run a single service with Fargate and EC2 on EKS? Yes. Can you do EKS and ECS? Yes. So the short answer is yes, you can have a single service running on EKS and Fargate and EC2. And EKS is going to help you scale and grow your clusters and nodes based on the demand. And if you use Fargate, actually, you know what? Let me do this. Claire Ligori had a really, really cool video that I liked to show in the past. Werner, right here. So Claire Ligori had this video. Everyone can watch it later on your own time. But at that moment, Claire talks about Firecracker. And Firecracker is the engine under the hood for Fargate. So it's the same thing that runs Lambda. It's the same thing that runs Fargate. So really high performant, high compute power to allow Fargate, which is the compute layer of EKS, to be able to scale on demand for a single application. And she does a really good job demonstrating that in the video.
Doyin, I guess your question have been answered, right? Or you
Yeah,
still
yeah,
have
awesome.
more?
That's good. Thank you. Nice.
Yeah, you're welcome. So I don't mean to send a link to a YouTube video and distract anyone. Like, please go watch that on your own time. Don't leave me. Don't abandon me. I love y'all. So stay here, but watch that when we're all done here. And then again, let me know if you have any questions, maybe about it. You can message me on LinkedIn if you would like to connect. Or I am rambling now. I'm going to drop my LinkedIn link one more time just to make sure that anyone who joined late didn't miss it. And I do see a question from Uneko. Did I get that right?
Yes, I think we got that. Let me check. think that's it. Is there any
Says,
question?
can
Okay,
you?
somebody asked, can you give us examples of cloud native applications?
Yes. Yeah. Actually, I'm gonna invite Uneku to come off mute and like correct me on pronouncing the name. I don't want to get it wrong. I'd love to get it right.
Okay. Where is are you sure he's here? I'm trying to Ejika. I'm not even sure I'm pronouncing it well. Please, if you're on the call, we want to hear you.
Yeah, that name is hard to pronounce. A lot of people have butchered it already.
Sorry. Sorry, please
It's
correct
a
us.
language name, Sha, so I don't really expect people to get it at once.
How do I pronounce it?
Uneku.
Uniku. Okay, got it. So Uniku wants to know examples of cloud native applications. Now, I can give you an example. We actually just kind of walked through one with the previous question about using EKS and Fargate and EC2. And I kind of talked about Firecracker under the hood. If you go watch that video, now I'm going to kind of piggyback off of my previous answer, but if you go watch that video where Dr. Werner Vogels introduces Claire Ligori, then what you'll find is Claire actually walks through an example of a real-time application. It's kind of a, hey, go to this website and do this thing during AWS reInvent back in 2019, I believe. Let me actually double check. Yes, 2019. So Claire is like, we just had a registration service. There's a whole lot of people coming here. And as more people start to register, the fleet scales out. But as people stop registering, the fleet scales back. So an example of a cloud native application would be something that's running on services like Amazon EC2 or Fargate and using EKS to help with that orchestration, the growth, the scale. You can use a web app server. Actually, you know what? Here's another cloud native application, AaronSHunter.com, shameless plug. That's literally just using CloudFront and S3 and Amazon Route 53 for DNS. Route 53 for DNS, S3 for my object storage, CloudFront to cache and send it all out. Oh, shoot. What do you see when you go to AaronSHunter.com? I'm actually curious. I think I have WAF or Web Application Firewall turned on, and I don't know if you can see it. Do you see error messages, or do you see like all my links?
Can you send the link to the group chat, please? So good.
I can, yeah. Let me do this because I think I have error messages.
Yeah, all the links are showing.
Cool. Okay. So I have another demo where, like, if you go to a different website, you see like error messages. It throws you to space. Like, no lie, if you do that. But here, like, this is my personal website, and it's nothing fancy, but it's something that I've shown in the past. You can get really complex with it. This is literally just an HTML page that has like images and stuff. Everything is stored in Amazon S3, and then I have CloudFront distributing it out. If you go to AaronSHunter.com, there's some other stuff that happens when you enter that in the browser, and Route 53 is taking care of all that for me. So very, very high level, but this is technically considered a cloud native application.
All right. Thank you very much. Thank you very much.
Yeah, you are welcome.
So sorry, Aaron. So apparently anything that runs in the cloud is a cloud native application, right?
Correct. It can be a simple one, like a simple website like I have here. It can be a more complex one where you have user registration that's venturing across multiple or dozens of AWS services. It can be something where it kind of sits in the middle. It can be interconnected. It can be going from one system to another system, from one account to another account.
Okay, thank you.
So,
Yeah, you're
sorry,
welcome.
can I ask one more
Kingsley has a
question,
question.
please?
Kingsley, you can go.
Okay. I'd like to ask a question about integration. Because of recent, I've been quite interested in using API gateway to integrate directly to certain AWS services. For example, instead of having API gateway pass data to a Lambda function before putting into a DynamoDB, I could just use gateway as a direct proxy to DynamoDB. I could do my mapping in API gateway. I would also like to do such things such as trigger code build, trigger code pipeline using API gateway directly. Do you think that is preferred to using a Lambda function in between? Would you prefer a direct integration from API gateway to AWS services, or would you recommend have a Lambda function in between?
I think I would need to like better understand what it is exactly that you're trying to accomplish, but essentially you could use API gateway to trigger a Lambda function. I would recommend considering either Event Bridge for more of like an event-driven architecture, or we have something new that's known as Lambda pipes. And I'm going to pull up that doc, Lambda pipes. Okay. Event Bridge pipes, which actually uses Lambda. But here, Event Bridge pipes, the link is in the chat. And I do see a couple of the questions in the chat, and I'll come back to them for anyone who's wondering, hey, why isn't he answering my question? I'll get to you. Don't worry. I'm there. So Bridge pipes is going to be something that I would recommend that you consider. You can use API gateway. You can use Event Bridge pipes. You can use multiple Lambda functions. Instead of multiple Lambda functions, I would actually encourage you to explore step functions, which can use Lambda as your destination or your source or your target. And then that way you can use more of a microservices, like a true microservices architecture. So now you have your call that's being hit at your API gateway level. That can go to Event Bridge or Event Bridge pipes, can also trigger a step function, which can then do other things based on whatever that flow looks like. You can have parallel tasks. You can have in order tasks. So you can say like, I want something to happen at the same time, or I want this to happen. And then based on the response from this, I want something else to happen. So you can kind of fork it off. All right. And then for those who maybe, yep, you're welcome. For those who maybe joined a little bit late, I see a question here. If it's okay, could you please do a brief recap of for people who joined late? I'm very new to cloud engineering and don't understand a whole lot. Yeah, so a brief recap. For those who joined late, hi, I'm Aaron. I'm a principal developer advocate with AWS Training and Certification. I've been with the company for about 9 years. I'm in my 9th year now. And I started as a cloud support engineer, worked my way all the way up to a tech trainer, and then eventually came over to the developer advocate side of the business. I basically work with people on their learner journey, their certification journey, and help to answer questions about different services and answer different scenarios. So we've covered so far is what's AWS, what is cloud native, what is not cloud native, and I'll kind of cover those real quick as well. We also covered different services like Amazon EC2, S3, SQS. EC2 is compute, S3 is storage, SQS is messaging. But let me cover real quick for those who joined late, what is cloud native? That's where you design an application, deploy an application, all within the cloud. In this case, AWS. And then we're going to talk about, or what we have talked about is what is not cloud native. It is basically when you deploy an application, not in the cloud. So you deploy it on a physical server. If you've ever written an application and deployed it on local host on your laptop, that is not cloud native. But if you take that same code and put it onto an EC2 instance and run it there only, that's cloud native. It's designed to run within the cloud. A lot of people also use infrastructure as code, or IAC, so CloudFormation, Terraform, stuff like that. And then that allows them to write code to scale out their fleet and then also run their cloud native applications and deploy it across one account, multiple regions, multiple accounts, or a combination of all of the above. I hope that answers the recap question. And also I threw a couple more information, a couple bits of more information there as well. I see someone has their hand up.
Yeah, Elizabeth, I think she has a question. Elizabeth, you can ask your question now.
I'm sorry, that was a mistake.
Oh, okay.
No. I want a question now. Think of one. Do it. We're all gonna wait.
So, does anyone have any other question? Okay, I think Benita has. Benita, you can speak.
Okay, hi, Aaron. When you did your recap just now, you said cloud engineering is when you design and deploy an application on the cloud. And I just want to know, does that also include like writing the code like on like a cloud server or something, or you still like write it locally then send it to the cloud? Like designing on the cloud, I want to know like what it entails practically, kind of. Like I get the deploying on the cloud side, but the designing on the cloud, I want to know if like you get to write the code there or like you just visualize it there first of all. Like what's that about?
Yeah. So what is cloud native? And like I talked about, I'm trying to like kind of piece together what it is that you're asking. So essentially what you want to know, if you write it locally on your laptop and then put it into the cloud, is that still cloud native? Yes. Now that's what's known as one of the R's for the migration patterns. Let me pull up the page here real quick. AWS migration. I think it's 7 R's. Give me a second. I'm going to pull it up. Iterating the 7 R's migration selection strategy. Okay. So there's a link in the chat, and I think this will make more sense if you kind of follow along with me. So let's say you design your entire application on your laptop, or if you're a hands-on shop and you only have your servers physically there, that is not cloud native. But then you're like, shoot, this is expensive. It costs a lot of money. You have the end of life on hardware. You have to upgrade your hardware and retire it. So how do you get away from that overhead and the ceiling of, it's called technical debt. So the technical debt of like stuff that you have to pay for every couple of years. By leveraging AWS or a cloud service, what you can technically do at that point is migrate. And here under the 7 R's section, here is another link that actually will send you to a diagram. Within the diagram, it does kind of a workflow, a flow chart. It's like, what are you trying to accomplish? Maybe this R is right for you. The 7 R's are, give me a second. Okay. Retire, retain, relocate, rehost, replatform, refactor, re-architect. That's the same one. Refactor, re-architect, and repurchase. So retire means like, hey, you have all this like equipment, this technical debt. You just want to retire it. You don't want to replace it. Or you have this technical debt that's hardware. You want to retain it and come back to your migration pattern in the future. Or you want to relocate, like let's say if you're using VMware on AWS. And I'm actually taking a look at the notes right now, the same page that I just linked to you. Or you can rehost. Rehost is what I was talking about. That's the scenario that I gave you, where it's an application migrating into AWS. You're rehosting it from your laptop into an EC2 instance, or you're rehosting it from your laptop if it's code only onto Lambda. So it's serverless. So the difference between EC2 and Lambda, once you've rehosted into AWS, is do you want to have an always running EC2 instance? You can stop and start it, but that's additional actions. Or do you want to have an on-demand, like as your code is called, that serverless function, the Lambda function is going to be called and then run, which means you're only paying for the invocations instead of paying for the hourly usage. So I hope that helps answer the question.
Yes, thank you.
Okay.
Nailed it.
Sorry, I want to also add something to that. So from what Benita was asking, my question is, for example, you've explained the moving from your local to a cloud. That's the migration thing you explained down. But what if you decide to write the code? Like, is it possible to write the code in the cloud without using anything local? You're not doing any migration from start to finish. It's cloud. Is it possible?
You can. Oh yeah, you can definitely do that. What I will do, Code Whisperer. So Amazon Code Whisperer is this right here. It is a coding companion. It's generative AI. Let me know in the chat. Have you heard of AI before? I feel like everyone has heard of AI at this point. +1 in the chat. Favorite emoji. Thumbs up. Do all the things if you've heard of AI. But essentially what that is the Code Whisperer is your coding companion. It's a integrated development environment, IDE in the cloud. You can actually launch it within VS Code And it's going to give you some cloud-based AWS specific examples of how to write your code. You write a comment, you're like, how do I, or write, like create an Amazon S3 bucket that can upload objects across multiple folders. It'll say, cool, here's some code that we can recommend for you. And then you, like with all prompt engineering tools, you have to trust what it says to a certain degree, but you have to kind of know what you're doing. You can reprompt it to give you some different output, but you can take that code, put it into a Lambda function, and run it solely within AWS.
Okay, that makes sense. Someone asked the question on the group chat. The person was like, if Code Whisperer is the same with Cloud9. I think so. You can
think of them as two different opportunities to learn. So Code Whisperer is a coding companion, prompt engineer type stuff that you say, output this, code. Output this, code. Cloud9, on the other hand, is a cloud-based IDE. So Code Whisperer runs within an IDE. Cloud9 is the IDE. So hand in hand.
Yeah. Okay. Slam, thank you for answering that. I think Slam has a question too. Slam, you go next. Wow, we have plenty of questions lined up. Slam, go next.
I love it.
Aaron, thank you for all that you do. Okay. So how you talked about migration from localhost as dev, right, to AWS, right? But how can you walk us through on how we could migrate an existing production application has gone live already? Let's say, for instance, it's hosted on Heroku to AWS. Now, so the architecture comprises of just background workers, right? A Redis for caching, right? Postgres for database, right? And it's actually a Python application, right? So how do you migrate that? And most importantly, how do you set up those background workers on AWS to ensure that you're able to manage that mini cluster, right? To avoid unnecessary downtime, right? While migrating.
Yeah, so in that case, I would actually do a multi-phase approach. What I would do is say one component of your application, one component of your enterprise level workload. Maybe it's the database only, and you do a cutover. There's going to be some downtime, but the goal is to reduce that downtime significantly or entirely. I don't think entirely is fully feasible unless you have an active pipeline. So you can do things like, what is it? CloudFront and Accelerator. So you can actually use like Accelerator, and let me pull up the docs on that real quick. Global Accelerator is a really good service to help you with this. So Global Accelerator, links in the chat, will actually allow you to send traffic to multiple destinations. They'll send certain percentage of traffic here, a certain percentage of your traffic over here. And the cool thing about that is you can send traffic to AWS. You can send traffic to your on-prem. You can say 50% here and 50% here. What that really benefits you, and this is similar with like an Elastic Load Balancer, Application Load Balancer, Network Load Balancer, but those are within AWS. What you would actually do here in this case is have Global Accelerator send 50% of your traffic on-prem, 50% of your traffic to AWS. And then you gradually decrease the number or the percentage that's going on-prem and increase the percentage that's going to AWS, eventually getting to the point where you have 0% going on-prem and 100% going to AWS. I would do that for every layer of your application and across multiple components of your enterprise deployments.
Okay, yeah, thank you. I think that'll be all for now.
Thank you too for answering that. I think Benita also has a question. Benita, you can go next.
Okay, just before I ask my question, I just want to see if I got this right. So the Lambda is something that is used when you're only hosting an app that needs to be running when it's invoked, and then EC2 is used when you want it to be like always online or like always present, right? And then when you're migrating your app from like a Heroku or Netlify platform to like a cloud service, you need to do it in kind of like bite-sized chunks, component by component, and until it's fully like assimilated into like the cloud service. I just want to check if I got that part right, first of all.
I don't think I followed the question entirely. Can you maybe rephrase it?
That's not the question yet. I'm just like checking if I got what you said right. So I'm repeating it to see if like it's correct.
Okay.
So,
yeah. So I'm sorry. Go ahead.
So Lambda is like the function you call when you want to use your app only when it's invoked, and then EC2 is what you use when you want your app to always be constantly online, right?
Correct.
Okay, and then for the migration from like a Heroku or Netlify platform to cloud service, you have to do it kind of like bit by bit, piece by piece, or component by component until it's fully assimilated into the cloud service, right?
Yes, that's the ideal approach. There's other factors that may play into it, like licensing may end at a certain time, so you have to migrate as much as possible. But the more you migrate, the more risk you're introducing to that deployment or to that migration pipeline. So you may have more downtime.
Okay. So my question now is, how does the cloud service handle like the size of the app or the amount of users the platform will onboard? Because some platforms will like grow with time, they will onboard more users and it will keep expanding and expanding. So like how does it handle the size of that? Obviously the database for that app will be growing, but the cloud space will also be growing. So like how does it handle that part in particular?
So how does it handle that in particular? I'm thinking like the migration and the growth at the same time. Is that what you're asking?
Yes.
Yeah. So when you're migrating and growing at scale at the same time, that's where introducing something like AWS with an active. So let me actually pull this up. I'm going to give me 1 second. Active, passive. We don't want that. Building active latency-based application. It technically falls under a disaster recovery workflow. So I'm going to send another link in the chat. There's a lot of links in the chat. I'm so sorry. A lot of resources, a lot of great questions. But if you pull up that link, what you see here is active passive is the first three. Backup and restore. That's where you basically upload all your images to Amazon S3, and then you eventually download them if there's some kind of failure or some kind of recovery operation. Pilot Light is where you have something running. It's ready to be run. I'll put it that way, but it's not running. So it might be an EC2 instance that's deployed. It might be infrastructure as code that you've already built out and tested. And in the event of some kind of failure, and keep in mind, I'm talking about failures and recovery objectives and all that kind of stuff, but it still applies to migration strategies because the same logic of having something quickly running over would be applied here. So the Pilot Light, you have infrastructure as code, you have an EC2 instance, it's not running, something happens, you start that EC2 instance, there's some maybe tens of minutes of downtime. Warm standby means that you have something running, but it's not fully production. It's not fully operational. It's there, and you can quickly get it back up to speed in just a couple minutes. Or real time. This is where I recommend that for any migration purpose or person, multi-site active, the one on the far right. Now keep in mind, that's the most expensive, but migrating something over and growing your base or continuing your usage patterns as normal without any interruption in your current existing architecture and fleet, zero risk to your minimal risk. I won't say zero. Everything has a little bit of risk, but you have to mitigate that risk. Real-time active deployment patterns will help mitigate some of that risk. So as you're migrating, as you're continuing to write to databases, you're migrating your database, your backends and so forth over to AWS using a service like Database Migration Service or DMS. You can also migrate your servers. You can write serverless code, all the different things. And then you eventually say 100% of the traffic on-prem, percent by percent until you get to 100% traffic in AWS at scale. I hope I answered the question. I also kind of gave some more information about like recovery time objective, recovery point objective, RTO, RPO, and all that.
Yeah, I'm still trying to wrap my head around it, but I think I got it.
We have about 15 more minutes that I can offer. So if there's more time at the end, I'm happy to circle back around
we have
to it.
2 more. I think we have 2 more questions. You asked us to ask you questions, so here are the questions. Adeni, you can ask a question.
Thank you very much, Aaron. This has been an interesting session. So quickly, in your experience, do we let's consider we have a production and a DR system, say on-prem to cloud or cloud to cloud. Do we actually have an active architecture or a very optimal, efficient active passive? I mean, when we're trying to bring the RTO and RPO down to almost zero, that kind of a thing. Like in your experience so far, does active really exist such that there is that automatic switch over and your RTO is really 0 second?
Yeah, so it sounds like you might be really close to active, if not already there. You're at least warm standby. So you have minutes of RPO, minutes of RTO, where you're able to flip over. When I think of active, I think of you have equally operating workloads. So you have, I'm going to use the word servers here. So it could be a server, it could be an EC2 instance or something. It could be a database, whatever. But you have 4 servers running on-prem. Could be another cloud provider, could be something, right? You have 4 servers running outside of AWS. And then you have 0 servers running in AWS. I'm going to build up here on this side. These 4 servers outside of AWS, that's your normal production workload. The 0 servers over here, that's kind of a problem. You want to fix that. So let's get that up to 1. So now you have more of a pilot light, but maybe that 1 isn't like fully productive. So if you have a failure, yeah, you can kind of get back to 4, but you don't want to do that. So you still have your 4 running outside of AWS. You have your 1, maybe now you have your 2 in AWS. This is like a warm standby. You're sending some traffic over in case there's a failure. You have 2, I know how to count. You have 2 outside of AWS and you have 2 over here, but these 2 within AWS need to scale. So now you have 4. Your goal is to get some kind of match. So you have 4 outside of AWS, multi-site active, you got 4 over here. Something goes down over here, now you have 8. Right? So your goal is to have some equal workload and balance. How do you migrate that with an active mindset? Let's go back to the 4 and 4. So now we're active. Something goes down. You purposely took that 1 down. Let me actually go this way, 3. So 3, and now you have 5. The goal is to always have 8 running in some capacity. You take another 1 down, and I ran out of fingers, but pretend like I have 6 fingers over here. Now you have 6. Another 1 goes down, and the goal is over here. You have 8, right? So you always have 8. I don't have 8 fingers, by the way. I'm not an alien, but that would be cool, wouldn't it? Did I answer your question? Did I make you laugh, at least?
Yes.
Okay. All right.
Thank you.
You're welcome. All right, we have just over 10 minutes left until I have to drop. The reason why I have a hard stop is because I have to take my kids to their martial arts instruction pretty soon. So it's Saturday morning. They like to go to martial arts.
Just one last question from Kelechi. So
absolutely.
Kelechi, you can ask a question now.
Okay, yeah. So thank you, Aaron, for the session so far. So I'm going to ask my question pretty fast. As we don't have time no more. So my question is, wrapping your head around AWS is quite a big process, I can say. So the thing is, I've been trying to post some of my applications on AWS, and choosing which one between EC2, Beanstalk, and ECR is kind of confusing. I don't really understand how it works. So I would like you to explain the differences and when to use which. Thank you.
When to use. Let me kind of turn the question back to you real quick and see if you can tell me what your understanding is, and then I can jump in and help solidify that a bit. I'd like to turn the questions around to tell me what you think you understand. It's not intended to embarrass anyone. There's no wrong answer, because in my experience, when I explain something and then someone says it's actually XYZ, that actually reinforces my understanding a bit better. So are you comfortable doing that? And if not, tell me, and I can just go ahead and provide the answer.
Yeah, I'm comfortable. Just go ahead.
Cool. And then if you get it right, you know what? That actually makes you look like a total, like, yeah. And if you get it right, what's going to end up happening is now all of your friends are going to contact you for advice. So you're going to be the pro in the room. So let me know your explanation of what you think, and then I can jump in and help.
Okay, you want me to explain what I understand between the three of them?
Yeah, just real quick. Like, let's see.
Okay, yeah. So let me get to it. So when I was checking it out, I saw that ECR is for container registry, where you can push your Dockerized application. So, but Beanstalk is kind of you connect it with your GitHub repository, and once you make a push, then the webhook will run again, and then the new one will be hosted. Yeah. So that is for Beanstalk, right? Then EC2 is for kind of related to Beanstalk, if I'm not mistaken. So trying to understand all of them is confusing to me. That is why I'm asking.
Yeah, I mean, like, you're so close. And I think the one thing that I can help say that might help you get to like the finish line is ECR is Elastic Container Registry, for those who don't know what that is. So you basically can put your code for EKS or ECS, your container deployments, or even your Lambda function, because you can actually run a containerized Lambda function pulling from ECR. So that's where your code sits. It's your repository for your code. Beanstalk is a different service. Beanstalk, you can use GitHub and stuff like that, but Beanstalk is really where your code runs, and then it's going to do all the other stuff within AWS. Fun fact for those who didn't know is Beanstalk actually uses CloudFormation under the hood. So Beanstalk will say, hey, you tell me your code and you tell me the configuration for your code. How many instances do you want? 1 second, sorry. Oh gosh, it's too early in the morning. So, hey, you give me your code and you tell me how to run that code. I'm going to go ahead and do it how you tell me. How many instances do you want? Across which availability zones? How many availability zones? Do you want a database? I can do a database for you. You want a load balancer thing? I got a load balancer for you. I got all the things. But you know what it does is it takes the configuration. It takes your commands and it says, I do as you please, sir. I do as you please. And it creates a CloudFormation template. So Beanstalk is really just a wrapper around CloudFormation running your code. What that means is it's still using EC2. So EC2 is really the engine behind it. That's it. So EC2 is there. It's going to launch all the different servers. And ECR, because you're using ECS and you're using EKS, you still have the option of having EC2 down there. So EC2 is your compute layer that can be used by Beanstalk, CloudFormation, or EKS and ECS. I hope that answers. But you were like so close, so close. I loved it.
Wow, thank you so much. I really get the point right now. Like, if I'm learning it from now, I will understand everything from now. Thank you so much.
You're welcome. And I give you a cheers while I sip my coffee.
Thank you so much, Aaron. Thank you. I'm guessing your time is up now, or I think another. Okay, the last.
I can do 5 more minutes.
Yeah,
I got 5 more minutes.
Yeah.
And
okay, I just quickly, I also want to add a few things. Thank you, Aaron. We all appreciate your contribution. We all appreciate everything you said. one thing I'm particularly interested in, one thing I love the most is you have documentations on hand. Like for everything, for every question that's thrown to you, there is a documentation. And I love AWS for documentations. I think AWS has the best documentation out there, literally. Like everything you're looking for is there. So I believe for someone going after a career in the cloud, documentation is important. Learning how to source documentation, study and read. Also, we have an expedition that we'll do. If you permit me to share my screen, we have this 12-week AWS challenge that we're currently on, where we pick an AWS service and we learn every week. Okay. So we're currently on week 7, which is containers. Next week is week 8. Then here we have our event-driven architecture, like you suggested. Then we also have Code Whisperer for week 11. I'd like to ask, is it possible for us to also see you probably during the week of event-driven architecture or Code Whisperer?
You know what I can do? I love to share the spotlight with my friends and colleagues as well. Code Whisperer, what's the date for that one?
Okay, we're currently on week 7, so that will be in 4 weeks then.
4 weeks from now.
Week 7. On the same day, like today?
Yeah, when the person is available.
Okay, 7. I gotta do the math. Hold on. Pull up my calendar. So week 7, 8, 9, 10, 11. On the 30th of September, is that right?
Yeah, week 7 ends. Week 7 ends tomorrow, so we're starting week 8 on Monday.
Okay. Yeah. Can you send me all the details of like when the dates are and when you would want someone speaking? I'll see what I can do. No promises, but I'll see what I can do about my availability. And then also if I'm not available, I'll see if there's another like developer advocate who specializes in that space. And maybe I can find someone to guest speak for you. No promises, but send me all the info and I'll do what I can.
That's awesome. Thank you.
Yeah, you're welcome.
Thank you so much, Aaron. It was nice. I'm from the comments and the feedback, you know that we really enjoyed this section. Thank you so much for acknowledging.
You are absolutely welcome.
Thank you.
Thanks for having me. My personal website is in the chat, so it has a link to my LinkedIn. It has a link to my Instagram. I'm on Threads. I'm on Threads. If you're on Threads, follow me on Threads. Connect with me on Threads. I'm on TikTok. I'm not very active on there. It's mostly embarrassing stuff. So if you want to watch me embarrass myself, go ahead and do that. But yeah, I would love to connect with each of you. I'm mostly active on LinkedIn, and I really loved being here. Thank you for the invite.
Thank you too.
Thank you so much, Aaron.
So we'll have more questions. We'll just get to whatever we are doing next. But
yeah, maybe I'll come back in a month. So if you have questions, send them my way, and maybe we can do another session in a month or so. I love answering all the questions and helping people on their learner journey. But you can also send me a message on LinkedIn, and I can try to answer there. I might have a delay. I see all the hearts. You know what? I throw all the hearts back to each of you. So thank you so much.
Thank you.
All right. Bye, everyone.
All right.
Bye. So, guys, the meeting has not ended. I think we're going to have Kingsley, right? We're meant to have a normal
revision.
Yeah. I guess everybody's pumped up already. Aaron did the trick.
Okay, that was an awesome session. That was really awesome. Thank you all that came online, those that asked questions, those that turned on their videos. It was really what will I use? Supportive, yeah, because his video was on, and it would only be fair for someone else to also turn on their video at the very least. Naturally, I don't turn on my video. I don't think I've ever turned on my video in any meeting, honestly. But because his video was turned on as a guest speaker, it's only courteous that at the very least one person should turn on. So I want to say thank you to all those that are able to turn on their videos too. And those that ask questions, I really appreciate it. Okay, so for this week's class, let me quickly just Hold on, let me check switch. Okay, I have to use the same thing. Yesterday we had a class on Docker, and we had Linda explain to us how Docker works. She showed us how she Dockerized her application and how she pushed the application to Docker Hub. Okay, so for today, I'm going to skip the part of what she did because there's no need going through that again. But in summary, I have my application. This is an application I'm currently working with. I'm trying to build a SaaS. So I have my application here. I have my Docker file. Like we explained, or like she explained yesterday, your Docker file is what Docker would use in creating your Docker image and pushing to your repository. So I have my Docker file. Uh, I'm using Node Alpine 3.18 as builder. I'm using the same version as my deploy. Now, if you notice, we have two Node versions here. As in previous examples, or like one we used yesterday, we had just one stage where she built and then pushed the application. However, in this example, we have two stages, right? I have the first stage, which I'm using Alpine 3.18 as my builder. I have a different stage where I'm using the same Alpine, but this time as a deploy container. Now, why I'm doing this is because I want my application to build in one container. Then I want the rest of the application to be deployed, or the image to be built in the second. Now, for this Docker file you see here is for my backend. Now, if you see, my backend contains two folders and multiple files, right? At the end of the day, I do not need all these files in my server. I do not need all these files in my running container. I only need, for example, gitjob.sh. It's just a file, it's just a script I wrote to help me with my Git submissions instead of doing everything one after the other. Create.sh is to help me create a stack. I have my setup stack also with the cloud solution template that helps me create my DynamoDB, Cognito, Amazon Cognito identity pool, and all that. I do not need any of these files in my Docker image. So the solution to that is creating two stages in your Docker file. This first stage will take in everything, because I'm going to push this to your repo. It's going to take in everything from here. It's going to copy. It's first going to create the directory, as has been explained earlier. I'll just walk through this very fast. It's going to copy your package.json file into this directory. It's going to run npm install in that directory. Then it's going to copy everything. It's going to copy everything I have here into the working directory. Then it's going to build. My build process now will convert my TypeScript into JavaScript. Once it is done, I only need 3 folders, or 2 folders rather. No, I need just 1 folder basically. So it's going to copy package.json, which is necessary, into this new Docker container. It's going to now run npm install. This time, I'm only going to install production necessary dependencies. In my package.json file, there is usually your dev dependencies, which are things you only need during development. For example, I only work with TypeScript. I work with TypeScript so much I forgot how to use JavaScript actually. So your TypeScript does not run on your server. TypeScript is only for your development. TSNO is only for development. Mocha, all of these are only for development purposes. The only things I need to run on the server are these guys in the dependency section. So instead of running npm install, I will install every single thing and push all of them to the server when I actually need only my dependencies. During my first stage, which is the build, I'm going to build everything. I'm going to install everything with npm install. Why? Because for me to run For me to run my build script, which is npm clean tsc, where I'm compiling TypeScript to JavaScript, I need to have installed TypeScript. And TypeScript is under my dev dependencies. So I will first have to install everything the same way to do on my system development environment here. After installing, then I will now run my build. TSC will now help me compile from TypeScript to JavaScript. So once it's done compiling, I have just the files I need for my production. I will now come into the second Docker container, Docker container that runs this build for me, and repeat the same process. I'm going to create my work directory. I'm going to copy package.json. I will now install the omit development dependency because at this point I no longer need them. I only need them to work in my local environment or in my development environment and build my application. Once I'm done building, I have artifacts that can run straight on the server. So once I do this install for only dev, I will now copy the folder that my application has been, my artifact has been built, copy into, which is here I call it www, that's the name of the folder. I just put run ls so that to show me all the files. Then my port is 8000. So it's going to expose my application on port 8000. What command should you use in running my application? npm run start. This is the summary of this part. Now, once I'm done here, I'm going to push my code into GitHub. In yesterday's class, let me switch over to the other browser. In yesterday's class, we had Linda show us how she used CS backend. We had Linda show us how she used GitHub Actions in working with her code. So in GitHub Actions, she pushed her code to GitHub Actions. GitHub Actions had the file that now orchestrated everything, right? Now, in our own case, we're not using GitHub Actions. I'm using AWS for everything I need. So I created a pipeline which contains a source and a build stage. My source would simply get my code from whatever repo I have chosen. Yeah, either my source is an S3 bucket, if I have my files in a zip file in an S3 bucket, it picks it up from there, or it is in GitHub, using GitHub 1 or GitHub 2, it could be GitLab, it could be Git Enterprises, it could even be ECR, it could be an image we're getting from AWS Container Registry. So that is what this source does. Once it has gotten the code, my code build would now do the same thing that GitHub Actions does. GitHub Actions is simply a container that is started and whatever code you've written is executed there. My GitHub Actions does the same thing. Let me quickly open my GitHub to show you file. So okay, let's start. I want to show you my build spec.yaml file. The build spec.yaml file is what tells code build what to run. It gives you the command, do this, then do this, then do that. And you specify that in a build spec.yaml file. So this is where I have my file here. And this is where it specifies all actions that should be taken. Okay, so this is a so basic commands. Yeah, first it would log into ECR, then it will build the container using Docker build. It will getting the repo name and tag name from the environment variables that I set in code build. And once it's done building the container, it's going to push. It's pushing the containers to Elastic container registry. If we come here, whenever we're done pushing either my client side or my backend side, it creates a container, it creates the image and pushes to any of these repos, depending on whether I set the repo to backend or frontend. Also, when I'm creating my image, I'm tagging my image twice. I'm giving my image a particular tag, and I'm also tagging it with latest. So at any point in time, I can go back and pick a particular image tag that I set, or I can just use the latest one, right? Sorry, was the hand raised by mistake or other person? Okay. So I'm tagging twice. So at every point in time, I'm pushing two images. I'm pushing an image with the tag, and I'm pushing an image with the latest tag. So if I go back here, we see that I have this image here. This is an image that has two tags, backend dev or latest. So if I have, let's say, version 1, version 2, I'll just come here and have V1, V2, V3, and I'll also have latest. But at any point in time, I'm going to have V1 to maybe V8. There's only one latest. The latest contains the latest version of my image. Then to display or to have my containers running, I'm using ECS with Fargate. ECS is Elastic Container Service, where you can, ECS is Elastic Container Service, where you can, that is a service that helps you spin up your images. You specify which image you want to run. You specify how many versions or how many containers you would like to run. You call it task. All this you specify inside and the task definition. The task definition is like, I want to run this container. These are the components of this container. This container uses some sort of environment variables. This is the name to do the container. This is the port of this container running. That is the blueprint. Your service would now specify how many versions of this container do you want us to run. Right? So that is why when you create a cluster, you create a task definition that specifies what and what. This is the first task definition I have, PLG1. I gave it a size of this, memory of this, storage, and all that other jobs. This is the container. So you specify all this. This is the container image I have. You see, I'm using latest. If I want to use a particular version, I will now come and say maybe backend dev V1, V2, or whichever one I set. I use my port as 800, and I'm mapping it to 800 of the container is going to run on. It has the port name. These are my environment variables, which I should not be showing. So that's basically that. So this is how you create your blueprint for the container you want to run using your task definition. Then in the cluster you create a service, right? Your service would now use this task definition you have specified to know how many instances it will run minimum, how many it will run maximum. Okay? In this case now, I set my desired instance to 1, and I have a maximum of 3. Innocent, your hand is open.
Yeah, for the tagging, I wanted to ask, when you have a new version and you tag it latest, does it remove the previous latest tag that you gave to the older version?
Yes. With AWS, no, you have to set it. That's why you saw those other extra ones on there. When I pushed in new images, yeah, it didn't delete the previous ones. It just created a new set. But it took the tags away from those previous ones and attached to the latest one. So these other ones don't have tags.
Yeah, I was just wondering about that.
Okay. So in this case now, I have already specified that I want a minimum of 1 container running, right? A minimum of 1 task running. The task definition specifies the image I want to run, the environment variables, and other things associated with that image. The service would now use your task definition to spin up a container and multiple tasks. So if I come here to tasks now, you see that I have just one. It is using revision 2, which is the second version of what I created. It's using revision 2. I have only one, so I specified one as my minimum. And this is the container that is running here, this backend container. So it's running multiple versions of my backend container. But here I specified only one. If I want two, you have two versions of this container running. I know you're following. Now, because I specified that I want a minimum of one, we have only one. I have a maximum of 3. This service that is running contains a load balancer and a target group. My tasks are attached to a target group, and the load balancer is attached to that target group. So that if I want to access the content of my container, I do not need to start getting the URL for each container or for each task. Why? Because at any point in time, this task can be destroyed and a new one is set up or a new one is brought forward. And I'll show you an example here. At any point in time, this guy can be destroyed and a new one brought forward. But because I have said I want a minimum of one running, if something happens, let's say I push a new code, yeah, it does not just destroy this guy at once. Instead, while this one is running, it will spin up a new container containing the new code I have pushed, run 2 of them side by side. Once it has verified that the new one is working fine, before it will delete this old one. That way, it reduces downtime. It's also part of either rolling, that most people say deployments, rolling deployment or blueprint deployment. In this case, we are rolling. We're not taking everything off at once. I'll give a live demonstration here, don't worry. Okay, Innocent.
You're mentioning versions. Are you referring to instances? Because when you say version, I'm thinking you are running and different versions of images or something. So are you referring to instances when you say versions?
When you say instances, are you referring to like EC2s or?
Yeah, you say versions of containers running. So is it that you have, if you are when you specify versions, are you referring to like
No,
you say 2 instances of the container running at any point in time or something, or versions is a different thing entirely you're referring to?
no, the versions here I'm talking about is the software or the application or the image rather. For example, this guy is running, this current container is running revision 2. In case you've made any changes to your code, right? And
Okay.
it is like, let's say you added a new feature. That is a new version of your image. So if you want your ECS to run the latest version of your image that contains that new feature, you would now go to task definition and then create a new version of it. This is the family name. Yeah. Then if I want to create a new, let me use 3. From 3, I want to create a new revision. So let's say
Okay,
I
so you can't
have,
just edit that single task. You have to create a new revision and then specify that revision to be the current.
you can do this automatically using code deploy. But for now, I've not integrated code deploy. I'm going to do that probably in next class or so. This is just a basic example. So with this, if I have a new, I can call this, okay, this is source. I'm getting from revision 3. If there's anything I want to modify here now, this is where I'll modify it. If I want to change the image that I'm using, if I don't want to use this current image, I want to use a different image, I come under this revision. If I want to change the name, I change the name. You understand? If I want to change anything I want to change about my stuff, I'll change it here. Then when I'm done, I'll just simply click on create and it creates a third revision. This is for the image that I want to run in the container. This becomes revision 3. Now let me quickly deploy. Let me make changes. Now for my load balancer, This is my load balancer currently on this. This is linked to my load balancer, right? If I go to status, I want us to notice this. Currently, if I hit my status on my load balancer, which is now targeting my application, it shows me status okay, and just added this stuff new, right? So currently, this single container running or this single task running, this single task we have running here is what is giving us this in our load balancer, because we have this one. If there are multiple, definitely it will be hitting any of them. Load balancer is spreading the load across. Now I want to go back to my code and make some modifications so that we see. Then I'll push. I'm going to change this new we have now to old. Then I'll save. Normally I use a bash script right for this. I don't know what I'm doing. Right. So once I push, the code pipeline will get triggered and it will build the new image. Okay, so let's leave this environment and let's go back to so if this refreshes, yeah, so stage 1 is done, stage 2 is currently in progress. So it's currently building using that build spec YAML file. Code build is building the image. After building the image, it will tag it and it will push it to ECR based on what I have in environment variables. I'm not coding any of the variables. So this is just how you implement CI/CD, integrating using ECS to run your containers. You can have multiple containers. You can have them in different task definitions. You can have them in single task definitions. Use that to automate your deployment process. So all you need to do is just push to your GitHub and the rest of the automation pipeline falls through. Your pipeline, you have your tests, you have your integration, unit test, and all that you add. When everything has passed before you now create, before you now push to code pipeline where to now build the image for you. So this is where it's building, tagging, and yeah. So the stage has succeeded. So succeeded. We're done with our build stage. Yes, Innocent.
Okay, yeah, I'd love if you could revisit the multi-stage when it comes to. I don't really get how the deploy process strips down your code base, because especially from that from the build line that you did. So I don't know. I don't really get how that occurs. It wasn't really clear to me.
I'll go back there. But for now, let me quickly just
all right, sure.
finish this part. Yeah. So currently I have my most recent version of my backend container. My backend image here was deployed at 1522, which is a few minutes, just like 1 minute ago. This is it here, just 80 megabytes. Now I currently have my old version, the old version of my application still running here because I still have new. I hope if I zoom this, I'm not zooming the entire browser. I should just do this one. Let's see. Oh, yeah, that's good. So I still have the old version here, which is still giving me new. Good. Now with ECS, if I had added code deploy rather to that my pipeline, so that after it is done building and pushing to ECL, code deploy would now trigger this guy to automatically update itself to the new image, right? But I've not added that. I was working on that shortly before the class started. So I'll add that later. But the point now I have a new image. I can just come here and update my service to use the latest version. I'm forcing it to deploy new containers, and I want it to use version 3, which I created the latest version. Let's assume this new version is one that contains my latest image, right? I just say force new deployment, do latest revision, blah blah blah, everything is the same. I get to update. Now if we come here, we see that let's give this guy a few minutes. We have one task running, but it will soon provision a different one in addition to this one. Why? Because now I've forced it to update and it's going to fetch the latest container for me. And it is going to run the both of them side by side. So you see it here. I have running and running. This one is still provisioning, while this one is currently running. This is running revision 3, this is running revision 2. If I go to my ALD, let's see if both of them are already currently working. Okay, it's still the first one that is running. Where's my this? Okay, this guy is still provisioning. Okay, both of them are running now. So it would now be, for now, to be swapping. Yeah, so you see old. This old is for the new one I just put in. This is for the one that was there previously. So you see there's no downtime, right? There's no downtime at all. I have my old application running, I have the new one running, and after some time, it would now delete the old one or the one that was there before. So we'll go back here and refresh. I think it's after 60 seconds or so. I set it to 60 seconds. Oh yeah, so you see deactivating. So because he has confirmed that this new one or this new image or this new container that's currently running is healthy, he goes ahead to deactivate this. So at every point in time, I require at the minimum one container to run. That is why it does not go ahead to shut this down completely. Rather, this one is running while it is starting up the second one. After about 60 seconds, and it determines that yes, this new one is healthy, you can now go ahead to shut down the next one. So this is how you can update your applications on a live server or live service without downtime with the help of ECS. Okay, so what I have running now is only this one I just currently pushed to production. There was no downtime. There was never any time you check the application and it told you could not access web page. All right, so these are some of the benefits of using Elastic Container Service. I'm using Fargate. I'm using an EC2 instance. Fargate is a serverless model. If after 30 minutes there is no traffic to my endpoint or my load balancer, it will shut down the Fargate instance, right? And whenever there's a request, it instantly spins up a new container or a new task for that container. So these two tasks you have here are running off this particular container with different versions, with simply different versions. Container for task. Okay, I won't have two here. Both of them are deactivating before. All right, that's cool. So the main thing is now, oh, he has deleted them. So I only have this one currently running because I set it to having just a minimum of one. If I had a minimum of two, I would definitely have two containers running. And whenever I force it to deploy a new version, it will first create one to make it three, then it will delete one of the old ones, then spin up a new one, then delete the second old one. That way you do not have downtime. So this is just a brief summary of containers using ECS based on this week's curriculum. Our time is fast spent. Do you have any questions so we can call it a day?
My question on the Docker thing.
Oh yeah, sorry. So basically, let's say, first, are you like a backend guy, or do you code, or this is just your
Yeah,
introduction to
yeah,
code?
back end, front end, generally.
Oh, that's good. So you know that after you're done, if you're using, say TypeScript or anything that is not vanilla, you have to build first.
Yeah, I know.
Good. Now that process of building, or when you're working locally, or when you're working with your dev, rather, let me use the word local. When you're in your development stage, there are lots of things you use in development that you do not need in production. Like the example I gave here is my package.json file. My package.json file for this particular guy contains lots of things for development, primarily because I am using TypeScript or I code in TypeScript. So in coding with TypeScript, I need the types of most of the things I work with. Those that do not have their own types yet. That's why I have all these guys here. I need ESLint. I need ESLint config Google. I need Mocha. I need TS Node. They help me create a development server for Node while I'm working locally. And I also need to install TypeScript. The dependencies contain the things that my application actually needs to run in a production environment or on an actual server. I do not need to use TypeScript in a production environment or in a server because Node does not understand TypeScript. You have to compile or you transpile from TypeScript down to JavaScript. So only during development do I need all of this, all of this. So if I'm now shipping my code over to production, I do not need to take all these guys along with me. It will only increase the size or load. Yeah, the size basically. It will only increase the size of my application at the end of the day. Also, if you look here, you see I have my .env file. I have build spec, the YAML. I have create sh Docker file. These files do not need to go into a production environment because they have no use. My application does not need any of these things. Build spec is only for code build. Docker file is only to build an image. Stack is only to build a stack. TS config is only for TypeScript. Same with TS lint. So I do not need to take any of these guys over to production. That is why when I am now building my image is supposed to contain everything my code needs to run in an environment without the person needing to install any additional resources apart from Docker. So when I'm bundling up my code, because I know that first and foremost I need to build in order to have the artifacts that is or that will be run on the server, right? I'm coding with TypeScript, but at the end of the day, it's JavaScript that run on the server. You are coding with React TypeScript. Is it RTX or what's the React? There's a React extension, something TX or so. That is not eventually what is going to run on your server. Everything breaks down to HTML and CSS. So, and JavaScript. Rather. So by building, you are creating the version of your files that the server would use. That is why we have the first stage. The first stage is going to be run as always in a container. Here I'm using Node, Alpine 3.8. I'm calling this container my builder. It's going to create the working directory first. It's going to copy my package.json file in there, because package.json file is what contains the dependencies. It would now do npm install, but this time for everything. It's doing it for everything because this everything I'm importing here is still the raw file as it is here. It is simply taking everything I have here as a raw file and working with it. So when I do npm install, I'm installing every dependency, both dev and production. Then I'll now go ahead and copy all my files from here into this container, then run npm build to build my files. The same way you do it on your local environment. When you are done building, it will now take your files or your artifact into a particular folder. It could be dist, it could be www, whatever it is. That folder is what contains the actual files that will be run in a server. The actual files that are needed for your application to run. At that point, I do not need to run TypeScript in the server. TypeScript is only to help me write efficiently without having bugs and without getting miserable mistakes at the end of the day. So once I am done doing this build, I now have this entire directory here, plus the particular directory where the build will put my artifact. My artifact refers to the code that has been produced that is now meant to run my application. So I have a collection of everything here plus the folders that are necessary to run my application in a container that has been referred to as builder. I have done stage one. I have built. So I have files I need and files I do not need in this folder. In stage two, I want to now package my application into an image. And the only thing I need is the actual file or the actual folder that contains the files that will be run in the environment. After I have finished building, I take the artifacts, and that is what I now use in building my image. Wherever I go, I must have a package.json file, because that is what will help me in creating my node modules. So I'll first and foremost, as always, I'll first call this now my deploy. And I'm going to create a working directory called /app. That's the default. I don't know what to do, but yes, that's the de facto. I will first copy my package.json, which is very important, into this app directory. I will now run npm install, but this time I do not need to install anything regarding the dependencies. Why? Because I have already used the dependencies to build my application. They've done their job. Their job ends in my development and building. My server does not understand TypeScript, so there's no point installing a node module that contains TypeScript. So I've done all of that jazz here, building my application. Everything I've built now will be in a file. Just as if you use the maybe Vite, for example, Vite vanilla TS. By the time you compile or you build your Vite, it packages your JavaScript, your TypeScript into the assets folder and gives it one random name .js. So it has transpiled from TypeScript to JavaScript. It is JavaScript now that your browser understands and not TypeScript. So the build it has done, I will copy my package.json file into this directory. I would run npm install, but this time I'm not installing everything. I'm only installing my production dependencies. That's why I'm omitting the dev dependencies. It will help in reducing the amount of files and folders in my node module. The next stage now, I'm going to copy from builder. Where is builder? Builder is this format container. Like I said, this container contains, after it has done building, the container contains everything that is here, plus that folder that now contains your build artifacts. So in my own code, I have told TypeScript TSC, when you finish compiling, please pack everything from here and put inside a folder called www. You'll see it on in my TS config file.
Okay, that was where it was confusing me because I was now wondering is www the build folder or because normally www is just for static files, but I just think that
And
you
no,
named
that's
yours.
what I call it. You can call it dist, you can call it whatever you want to
I
call
usually know
it.
it's called dist or
By
build
default
something.
is dist.
Yeah.
Yeah, by default is dist. So
I
but I use www. So wait, this one is for clients. So when TypeScript has when TSC builds, it creates a folder called www and dumps all my JavaScript files that it has transpiled there or compiled for me. So I will now say, okay, since I have that build folder in that previous container, oh yeah, go to the previous container called builder, go into its app directory, look for www, copy everything there, and come and put it inside the www here. So that in this place now, I will now have only my www folder, I will have my package.json, and because I have done npm install, I also have node modules folder. You understand? Then
yeah.
I did this run.ls to show me the folder list. So this is the breakdown of the two stages. I'm using this to build, then I'm using this to package my application into an image. I do not want all the jargons, I do not want all the baggage that comes with development. Everything should end here. Once you are done building, once you are done refining the carbon from black into the shiny one, please pass it on to me. That's the only thing I need. All the stones, all the ore around the body, I don't want it. This guy handles only the main stuff. So let me go back and before we conclude, let me show you how or where it listed all those folders from the log. So this is where it's doing everything. It contains the directory as copied package of JSON, copy everything. Okay, it didn't even list them accordingly. But let me just take it to the end where it does everything then. So see here at the end of the day, the only folders I have is what? My node module, which is a folder, package.lock, package.json, and www. That's all. All those other plenty src, ts links, ts config, none of them make to the final folder. So this is the only thing now I need to run my application, and this is the only thing that is part of the image. So that's why my image size is quite small, 80 MB. The 80 MB there, about 50 MB or so, is basically is from Alpine, the Alpine 3.1 something. So with multi-stage, you do your build in one stage, take only your relevant package for the second stage. The same thing I did for my client for the client's view. The client has lots and lots of folders. There's front, there's public, there's views. I only needed public views and my package.json. That's all. Every other thing can scratch themselves when I'm done. So I believe this answers the question you're asking.
Yeah, totally. Thank you.
Yeah, thank you very much. Do you have any more questions before we call it today? All right, thank you very much, everyone. Okay. Uneku.
Half a sorry, my attention was half and half because I was on another call at the same time. I wanted to ask, while you were setting up the ECS, is there any other thing that we needed to set up, like maybe I don't know if you did it or if it was, maybe it's for another day, the ECS. Is there any other things that you need to create, like should I say, IAM role and maybe ECS definition, or sometimes you can just go straight through the portal?
I did everything from the console. First, you have to create your cluster. After creating your cluster, this is this. After creating your cluster, then you come and create your task definition. Your task definition will determine which containers you want to run, how you want to run these containers, in what capacity do you want to run the containers. Do you have environment variables for them? Like that, like that. Do you want to use EC2 instances or do you want to use Fargate? Or you want to use both? Architecture default network is this VPC. You come here and select the type. Your execution role will be ECS start execution role. I think there's a default role for that, or it's actually to create one. If your container is going to be creating something on AWS, let's say it's going to be creating an S3 bucket or whatever, you now have to create the role for that and attach it here. Because I'm not doing anything like creating an S3 bucket or whatnot in my container, then I don't need to put that particular role here. Your container name, your container URL. If it's a private container, private registry outside ECS or outside AWS, then you come here and put your authentication. The port that your container is running on is what you put here. Protocol, port name would come here by default as a type. You can change it if you want. All these other jobs. Then environment variables that your container will use. Your container environment variables will use. If you want to put them one by one, you can create your container, you can create your environment variables in a file and put them to S3 bucket. Then you come here and put the URL, I believe, for the S3 bucket. .env. The same .env file you have in your browser, sorry, in your VS Code. If you want to strictly use a .env file and not come here to manually put environment variables, when you create your environment, you can do it as part of your CI/CD pipeline, in fact. Yeah? Create your environment variables, copy it into an .env file, which is an S3 bucket. There's a CI/CD pipeline I created some months ago. I showed it here in the last week or so. That was what we did. We copied out all the environment variables we get from the environment, copied it to a .env file, then pushed that .env file for next bucket. So that when all the instances are running, they get the same env file and use it as environment variable instead of typing it here manually and after the other. Then these are for logs, the health check, container timeouts, and all of that. If you want to add a factory volumes to a container from there, then when you are done with create. Then after creating the definition, you're giving your ECS the blueprint. This is the container I want you to create, or this is the image I want you to use to create containers. These are the parameters of the image we use. Then you now have to go and create a service. The service is what you now do the orchestration for you. So you create a service, you use launch type, Fargate of ECS if it is wrong. Then you are creating a service on the task command. You don't need to do revision manually. Just pick find the definition, so automatically pick the latest I believe. Yeah, pick latest. You pick a name for it, then replica. Then the desired task. That is the desired number of containers you want. If you pick 2, you are going to have a minimum of 2 containers running at any point in time. deployment options, you have rolling updates. Why is rolling updates fit? I should have a way of specifying. This is for VPC. Right. Okay, down to the right. I'll have to edit this video. I have this video transferred. So yeah, we're creating a service. So the service, you go down, the deployment types. I should be able to select, what is not selecting? I should be able to select Blueprint deployment here. Unless it's one I'm using, maybe it's the only one I'm using code pipeline. I use code pipeline next. So I can do Blueprint deployment. Use rolling updates, minimum number of tasks at any point in time. If I have my desired task to be 2, it means at any point in time, the minimum should be 100%. So even if I am updating, I must have at least 2. That is why, as we saw, because I put 1 as my minimum and I put 100%, it means when it is creating a new one, you cannot delete the one that's already running because I've said I want a minimum of 1. So you must run side by side with it. Then when you are stable, you cannot delete the other. Maximum number 200%. If I put 300%, then I can have like 3 during the whole deployment process. So yada, and we're good to go. We are going to create. Okay, let's see.
Thank you very much. Thank you.
You're welcome.
Okay, thank you, Kingsley. Yeah. So my question would be, was there a session where you explained all these procedures, how to set up your ECS and maybe ECR and so? Was there a session for it?
No, I've not done that, but it's part of the curriculum for this week. I don't know if are you new to the group?
Yes, I just joined 3 days back, I think. Yeah.
Oh, okay. So we're on AWS Expedition. That's what I showed this guy, Aaron. We're on AWS Expedition, and each week there is a curriculum. So this week is with ECS. I shared the resource for that. It's on the website actually. So what we normally do at the end of the week is like a revision. Yeah, I'll post it on the group. It's on the group. If you check one of the King's chats, but I'll post it on the group later.
All right. Yeah. Thank you.
All right. Thank you. You're welcome. Okay. I believe we call it today. There are no more questions. I applied to the. Okay. Please remind me to share the Docker file because I would most likely forget. Please remind me. Then I would apply for the Slack channel, please. Yeah. Once they check the request, they will add it to the WhatsApp to the Slack channel order. Any chance you could get the docs for this session? Like the docs, is it for me or for Aaron's part? Please, I'll go first. The person is still here. Okay, so that's okay. These docs you're referring to, is it docs for Aaron or?
No, for the thing with the I didn't really follow.
Okay, I don't have any docs per se. I'm really just having a live hands-on class. But I will share. I'll share. What?
I think there's a recording. Maybe I'll just do that.
Yes, hopefully I'll be able to. Hopefully I'll be able to get a recording. I'll be able to get a recording for this one. Yeah, I'll share documents, videos where you can do this. Even for Docker, like Linda mentioned yesterday, if you go on YouTube and search Step with Nana, she has like wonderful videos on Docker. If you are new, even if they are not there, she has very wonderful videos. So she has a 3-hour Docker course and all that, and other smaller ones. It will help you understand Docker. But if you are just starting, please, you cannot start with Docker. If you are new to the cloud, Docker is not the place to start. You get to Docker later.
Thank you.
All right, you're welcome. Okay, if we have no further questions, I believe we can call it a day. Is Kosi still here?
Yes, I'm still here.
All right, over to you, Bruce.
There's nothing else, John. Thank you so much for
Sorry, I would like to
conversation.
ask, please. Kingsley, are you still there?
Yeah, I'm here.
So someone dropped a message about having access to the recordings for the past sessions. Can we have access to it, please?
Most of our sessions are live. They are not really recorded. It was just yesterday we recorded. I think we
After
recorded
recording.
yesterday's one and this one. So most of them are live. Yeah, just live hands-on stuff. I only did slides the first 2 times. After that, I just come and use stuff directly.
Okay.
Kosi, for your class, did you record?
No.
Okay. I think just yesterday's one and this one. Probably going forward, we put recording right now.
Okay.
All right. Thank you. You're welcome.
Kingsley, thank you so much for today.
Thank you for hosting
And
today's
thank
class.
you, everyone.
All right. Do have a lovely weekend.
Bye, guys.
All right. Ejika, Uneku, you still here, what?
Yeah.
You're holding the next class. Thank you very much.
Wahala, wow.
Yeah, I like this random
No
selection.
wahala.
That's what we'll be doing.